Okay, so we're gonna use metal to identify whether or not it is an acid or a base, right? Then the other thing we're gonna use is our good old conductivity tester. So we used this when we were doing the properties of a metal versus a non-metal. Remember that metals, here's your metal, conduct electricity. And so when you touch this conductivity tester to a metal, it's going to light the light bulb, right? Now, if the light bulb is really, really bright, it means that you have something that conducts electricity really, really well, okay? If it faintly conducts, then it's what we call a weak conductor. And when we're talking about liquid solutions like acids or bases, then those things are going to conduct electricity through the solution based on whether it has the positive or negative ions that are all broken down into the solution and can carry the negative electron charge. So what we're saying here is, remember that the flow of electrons, so the electrons come off the battery, they go down one side of the probe, and then they go through the solution or the metal, and then they go up the other side of the probe, and then they go and they make the light bulbs light, because there's some circuitry stuff wired in here, okay? So if we have a solution that conducts electricity, then we're gonna have the positive or negative ions that are going to allow the liquid to carry the charge through the liquid solution up and over. So acids and bases will have positive or negative ions dissolved inside of the liquid based on whether it's strong or weak. So this is the tip we're going to use for strong or weak. So if it's strong, a strong acid or a base means it 100% ionizes. Remember, that means that it's going to break apart into positive and negative charged ions. That's a strong acid or base. If it's a weak acid or base, that means when the acid or base hits the water, it's only gonna weakly, very, very faintly break up, like less than 5% or so. So that means that you're not gonna have a lot of ion charge, which means, you know, barely any positive, negative charges that are breaking up in the water. Therefore, we're gonna end up with something that weakly lights if it's a weak acid or base. You should only see a faint light bulb, or a strong light bulb if it's a strong acid or base, okay? So that's our other tool in the toolbox. We'll know if it's strong or weak, acid or base, either one, based on how strong the light bulb lights up. Another definition for you here is that's also a term called electrolytic solutions. So electrolytes means they have a lot of ions that are floating around in the solution, like Gatorade, electrolytes, right? So you've got a lot of positive, negative ion charges, like the cations and the anions are all running around in that water, and that's the electrolytic solution. So for this one, we're just going to use the conductivity tester to see how much of an electrolyte we're dealing with. If it is a lot of positive, negative cation, anions floating around, then you have a strong electrolyte. If it's very faint light bulb, then it's less positive, negative cation, anions floating around in the solution, and it's a weak electrolyte, okay? Now, acids and bases aren't the only ones that are considered electrolytic solutions or not, because they conduct electricity and they have ions in them. Things like salt water, okay, would be a good conductor of electricity, because as we already learned, ionic compounds are made of positive, negative ions. And so like table salt or something, if it were to hit the water, it would break up into the positive, negative charge, and it would conduct electricity. All right, and the last thing we're gonna do here is we're just gonna, after we say, I think this is this and this, we're gonna write down all of our notes. You're gonna do it along with me in Pear Deck. And then we're gonna test to see if we're right by using some pH paper, which will tell us the pH, and also a universal indicator, which will change in the color presence and match it up with the chart to see what pH it is. And then last, we'll use our good old red and blue litmus to see if it's an acid or a base. So let's go ahead and start.